Welcome to another physics class. Today we want to continue with our topic, that is terms used in motion. In our last lesson, we look at position, distance, and we promise to continue on displacement today. Now, displacement simply means the measure of distance traveled in a specified direction. That is, measure of distance traveled, displacement, is measure of distance traveled in a specified direction. Measure of distance traveled in a specified direction. At the same time, displacement is a vector quantity. When you say vector quantity, it means vector quantities that has both magnitude and direction. Quantity that had both magnitude and direction. That's what I mean by vector quantity. Then again, the unit of displacement, the unit is meter. Don't forget, we done something like this in one of our lessons. That is, displacement deal with direction. For instance, when you say 2 meters, that's magnitude. But in what direction now? It can be in east direction. So it can be any direction. It can be east, north, south, or northwest, or southwest, or any direction. But the only thing is that direction must be there to make displacement. Now, let's look at differences between distance and displacement. Number one, according to the definition, distance is measure of separation between two points. Measure of separation between 2 points. By displacement is measure of distance traveled. Distance traveled in a specified direction. Number two, distance is a scalar quantity. On the other hand, displacement is a vector quantity. Another point, distance has no specific direction. While on the other hand, displacement followed a specific direction. Number 4 difference. Number 4, distance between two points is summed up by ordinary arithmetic method. Why displacement? Displacement is summed up by geometry method. These are possible differences between displacement and distance. Now, the next thing is similarity between the two. That is similarity between distance and displacement. 1, both have the same unit, and the unit is meter. Number 2, both are fundamental quantity. Both are fundamental quantity. Now, let's look at the sample under the distance and displacement. The first example, a ball is thrown from point A to B along a straight line with distance of 5 meters. The ball was thrown back to point A along the same path. Calculate the 1, resultant distance, 2, resultant displacement. According to the question, from point A to B, let's say this is point A, this is point B, the distance between them is 5 meters. But the ball was thrown back along the same path with the same 5 meters. So we are now asked to calculate the resultant distance. Now, the resultant distance since we said distance is a scalar quantity, then direction has no effect on it. So the resultant distance will be 5 plus 5. 5 from A to B, and from B to A, that's another 5, equal to 10 meters. But in case of resultant displacement, Displacement on its own is its vector quantity. Direction has the vector on it. So 5 meter to A, that's 5. Now in opposite direction, and 5 meter to B, then in opposite direction to A. Since they move in opposite direction, that's 5 minus 5. The answer will be 0 meter for resultant displacement. From here now you can see the difference as we said. Now this is another question. Two balls, A and B. A moves 4 meter and B moves 9 meter due east direction. Find their resultant displacement. Solution to this one. Now, let's say this is A move in this direction east 4 meter. And this is B move in this direction 9 meter. Now, their resultant displacement will be equal, since they move in the same direction, it will be equal to 9 plus 4. That will be what? 13 meter. That's all. Let's take this one as example 3. The bird flies 5 meter due north, then 4 meter due west. Calculate the 1. Resultant distance, 2. Resultant displacement, 3. Differences between 1 and 2 above. Solution. Four meter, 5 meter due north. This is north direction, 5 meter. You then say to west, 4 meter. So the fourth question says you calculate the resultant distance. One now, resultant distance. As we said, since distance is a scalar quantity, it will be 5 plus 4 equal to 9 meter. For resultant displacement now, 2. Displacement is a vector quantity. Then we use ordinary arithmetic method for this one. For displacement, we need to use the geometric method. Join this line together, and this one will form a right angle now, triangle. And once you have a triangle like this in mathematics, the best method to solve the problem is Pythagoras theorem. So this is our resultant displacement now. To find that one, it will now give us r d square is equal to 5 square plus 4 square. That's from mathematics Pythagoras theorem. Then it will now give us r, that is the resultant displacement, will now be equal to square root of 5 square plus 4 square. That one will now be equal to 25 plus 16. Now, the addition will be square root of 41, which is equal to 6.40 meter. Question 3 asks us to find the difference between the resultant distance and resultant displacement. Difference now will now be equal to, for resultant distance is 9 minus 6.40. Now the final answer will be 2.60 meter. Now, let's take another term. And the next time we are going to take is speed. What is speed? Speed can have the following definition. One, speed is rate of distance the rate of distance. That's number one definition. Another one, number two, speed is distance traveled per unit time. 3, speed is the ratio of distance traveled to time taken. From the definition we have on the board, you can now say that it's only the language that's being changed, but the term there are the same. Rate of distance. In rate, time is there. So that's why we say rate of distance. The second one, distance traveled per unit time. Distance and time are the major point. The third one, ratio of distance traveled to time taken. So the major thing, vital point you need to take note when you are defining speed is distance, then time. Mathematically, we can now say speed V is equal to distance over time taken. That is, V is equal to distance over time taken. Now, the next thing is types of speed. Types of speed. But before then, we can now say here the unit of speed. Unit of speed is meter per second. Meter per second. Don't forget, we're done with all these things in one of our lessons. Now, type of speed. We have 1, average speed. 2, uniform speed. 3, non-uniform, or you call it variable speed. And number 4, instantaneous speed. Let's take it one after the other. Average speed. Average speed is total distance travel per unit time. That is, average speed V is equal to total distance over time taken, which is equivalent to V is equal to total distance over time taken. At the same time, the average speed can be average speed V will be equal to U plus V over 2, because we call it average, where U equal to initial speed and V final speed. When U initial speed, V final speed, that is the point where the object starts to move, where the object finishes its motion. Now, the second one, uniform speed. Uniform speed occur when the rate of distance is constant. When the rate of distance is constant. Now from here, if you want to use the second definition, you can say uniform speed occur when the distance traveled per unit time is constant. Or you want to use the third definition, we say occur when the ratio of distance traveled to time taken is constant. Well, because of time, let's stick to this one for uniform speed. That is, it occurs when the rate of distance is constant. That is, as the distance is increasing, time also will be increasing at the same rate. That's uniform speed. Then number 3, non-uniform or call it variable speed. Just the opposite of this one. This one occur when the rate of distance is not constant. That is, when the rate of distance is not constant. Take the second definition, it will occur when the rate of distance travel per unit time is not constant. That is, the rate at which the distance and time will increase will not be at the equal interval of time. Taking third definition also is the same thing. Now, number 3, instantaneous speed. Instantaneous speed. Instantaneous speed is rate of distance at short time interval. The rate of distance at short time interval. Or if you want to use the second definition, it will be the distance covered per unit time at short time interval. Then the instantaneous speed, V instantaneous, is equal to the delta D over delta T. That is the rate of distance to time, the rate of distance at short time interval. That's instantaneous speed. Now, don't forget from our previous lesson that we made mention of instruments used to measure speed, either instantaneous speed or any speed. The instrument remains the same, which is speedometer. The instrument used to measure speed is speedometer. And now, this is convenient point to stop for now. In our next class, we are going to look at another term, which is velocity. And as I always say, if you are new to this channel, you want to enjoy this class more, please don't forget to like, share, and subscribe. So when I post the new video, you'll be able to get the notification in time. Thank you.